know you guys went over some of the basics of these stuff. To begin with, though, I want to actually start with doing a couple little competitions here. So, can I get 2 volunteers? Anybody? It's going to go up. It's not going to be nothing really. It's going to be really basic. 1, and come on, give me 1 more. 2. All right, come on up here. All right. So, who wants to be Team Purple and who wants to be Team Blue?
Andrew wants to be purple.
All right. So, purple, you're blue. Okay. So just move around here. Just slide around here. So it's tough to see, but right here we have a penny on each side. We're going to see. Take the dropper. You're going to drop individually and see who can put more drops onto the penny. So let's see quickly. Unfortunately, you guys can't see it very much, but
That's far out.
all right. Yeah. All right. So the next one I want you guys to do is now. What you're going to do is you're going to try to essentially take it, balance it on there, and you're going to try to lower it into your substance and try to float the paperclip on the top. So, all right. So one substance it floats on, one substance it doesn't. And then finally, we're going to do one more thing that I want to use as an example. Thank you guys, but thank you very much. I appreciate it. Yeah, what's wrong with you? You can't get it? Keep it up? So, with those 2 examples, so what do we think these 2 substances are? Does anyone know?
Alcohol and water.
What?
Alcohol and water.
Alcohol and water, yes. So this one's alcohol, this one's water. So what we're going to look at today is the first 2, at least in the first one, is why these 2 things happen. So that essentially that it's still, I'm shaking it and it still is not spilling over that water there until I finally broke it right there. But that so essentially that why it is that the water can stay together and also have the forces that lead to it to essentially that we can literally float a paperclip on top. So the question that this is really leading to is why water? So I mean when I say why water, I'm kind of asking you why. I mean you're taking an environmental science class, so that's looking at the sort of the environment and how life functions within that environment and why that works on planet Earth. And the basis of all of that and the most important substance in all of that is water. And so we're going to look at how these properties, these 5 properties, are 5 reasons why if we had substituted, say, that alcohol, that isopropyl alcohol with water, how the Earth would be a very different place and would not be a place that could be sustainable for life. So we're going to go back to those things first. But so what property of water makes it so distinct? Gives all those distinct properties that you see. So what is the nature of water? And I know Mrs. Branoff told you this yesterday. She mentioned it. She taught this to you guys. What was the property? What did water have? And what causes this? Where do those hydrogen atoms come from? What is the property of water that has? You're completely right. But what is it about water that makes it be able to form? It's polar. That is the big thing, and make sure you guys all have that noted, that water is polar. Now, what does polar mean? When you guys think of polar, what do you guys think of as polar? Anybody? Like, when you think of polar? Magnets, ice cap. So, it has N. So it is essentially like a magnet in terms of it has when you look at the water molecule, which looks like this, it has what we call a dipole. So we use this, which I believe that's what, delta? Lowercase delta, the dipole symbol? Yes. Yeah, that's the lowercase Greek for delta. And so essentially, what all this is saying is that there's essentially that it's got, that on this side of the molecule, it's negative. On this side of the molecule, it's positive. So that is the nature of that is pretty much causes all 5 of these properties that we see that in the in water that gives it these distinct, as I said, gives it distinction. So what that does is, as you said, it forms these. This allows it to form, first of all, these H bonds, hydrogen bonds. So the hydrogen, which is positive, as we said, connects to oxygen, which is negative, and that then can expand, and this can keep going. Slide over this. anyway, so you can see this, so it can keep going, and these O's, so O, H, H, and then you have these guys, O, and it keeps going on forever. So if you can imagine, it's almost like a lattice work of these H bonds that cause it. I mean, it's actually interesting that people talk about how, as much as, even in a liquid form, that when water functions as a liquid, it's kind of almost as much a crystal as it is a liquid, and, and that's what it gives it that very distinct sort of feel of how it is. From attraction of water molecules to other water molecules creates which one of those properties that we talked about? Does anyone remember that? I'll give you a clue. That's what we did the example of over here. What? Surface tension, yes. It's on the top. I mean, this allows for some really kind of cool things, like, you know, as I said, you can float the paper clip on top of the water. Same way that you can see those bugs. Sometimes you see bugs being able to essentially walk on water, and all sorts of things can essentially be held up and be supported by the surface tension. This cohesion also has one other really, really major thing for the ability of water to really function in the environment. So, can you put the top one on, please? Thank you. So this cohesion has one other really big thing. So when you think about it in the liquid form, what other thing in the environment do you think that this cohesive force is actually very important for water that you see every single day? Where else do you see water every single day other than like in lakes and in ponds and everywhere else? Where does that rain come from? Clouds. Clouds, yes. So this cohesive force, this thing, this surface tension, is also what causes clouds to form. Because again, it causes, if most things when they evaporate, they're going to want, most gases want to expand, right? You go and you see gas, it usually just wants to expand, and it kind of dilutes itself in the air and sort of spreads out. But the same cohesive force that causes that surface tension also causes clouds to come together and allows for that transport through the water cycle that you're going to be learning. So you're going to be learning about throughout the year. So that water, it doesn't just these strong polar bonds don't just bond and want to react with just water molecules. They really can they want to react with anything that has any sort of polarity at all. So that creates the second force, which is water with another thing called adhesion. So think of like, you guys ever hear like an adhesive, like glue? So yeah, it wants to essentially glue on to other things. Water's going to want to creep up on that tube, and that creates what we call capillary action. And I actually did a little example here of capillary action in action. As you see, look at how when I put it in the alcohol, there's like the liquid goes up to about here, but literally in just a few minutes we've been here, just by putting the bottom up here, the water is already down to here. So what happened there is essentially the water molecules here just kept on latching on and keep on latching on and latching up through the paper towel. Rather than the alcohol just kind of, I mean, it has a little bit of reaction, but then the forces just aren't strong enough to keep it going all the way down the way that this will eventually, by the end of the class, will soak up the whole thing. So this is capillary action, as I said, in action. Than anything pumping at all. How do we get, and furthermore, all that water comes from the roots, and how does it get to the leaves and everything else in the tree? How is water able to climb up all the way from the ground, beat gravity, and make it to the leaves? Well, the answer is a mixture of just pressure pushing. They have some pressure action that do it, and the big thing is it keeps them. It has this capillary action, this capillary force, keeping on pulling it up and making sure that we can get that water through those trees and hydrate them and make them be able to grow and function the way they do. If we had any other substance, we wouldn't be able to do that. If we were based on alcohol, that couldn't happen.